I'm Amanda Crowther. I was in charge of the electrical portion of this whiteboard assembly.
Hey, I'm Andrew Roth. I was in charge of the CAD design as well as assembly of this machine.
I'm Nicholas Hobart. I was in charge of the pneumatic design, engineering, and assembly of this automated whiteboard cleaner. So for our project, we chose to do the automated whiteboard cleaner. We had a couple different designs set in place, but we had like a cylinder draw, but in the end we decided to go with a clamping system and 2 electric motors to drive it back and forth. We also have an automated sprayer so that it can spray down the board. And we have spring tensioners pushing down on the erasers so that you're actually able to wipe something off. We kind of thought this is good for teachers who can't reach up high, or if they just want to push a button and have it go back, wipe, and then come back. We have 2 separate modes. We have an auto mode and a manual mode. So in auto mode, we have 2 inductive proc sensors here. When you push the green push button, it'll go down, sense that there's these end panels here, stop, and then come back. And then in the manual mode, there's a left and a right button, so you can just run it left or run it right. And then in the manual mode for the sprayer, there's a push button for it. And in the auto mode, it's on a timer.
Okay, what we have going on here is our electrical panel. As you can see, we have a row of fuses right here, and some fuses going on right here. And then there's some contacts for power here. All of the orange contacts are for power, and you have 2 red ones here for just linking your PLC to the device of the black wire. And then you have your blue, that's ground, obviously. Of course, we have the exciting device over here. That's going to be your PLC. And then this giant box sitting next to it awkwardly with only a few wires is going to be your power source. Now, when it comes to a PLC or any electrical panel period, first you need to get down an idea as to what you're going to be doing with your PLC. And that's where things like this come in handy. This is my electrical schematic of exactly what's going on here. What's up here is actually just your contacts. That's showing you which contacts are going to be closing in order to allow flow in the circuit. Then, down here, you've got your solenoid that goes to the actual cylinder. Then you have solenoids for each of the relays that we had to use in order to actuate these relays. Now, what we have going on here isn't just a normal circuit. What we have going on here is going to be what's referred to as a reverse polarity circuit. That means you're literally going to take your motors that are up there on the whiteboard.
It would drip on the whiteboard. And that's pretty much all there was to the pneumatics.
So I was in charge of the CAD design of this project. We had 8 weeks to design this and 8 weeks to build it. So this is the board, the arm that is clamped onto this whiteboard assembly. Here we have the electrical panel. This is the ball screw assembly. Normally you'd actually use a professionally made ball screw assembly, but our budget did not allow for that. So in order to get the clamping force of a ball screw assembly, I improvised and made my own ball screw assembly out of 2 bolts partially threaded and 1 fully threaded bolt with a handle on it. This gives the exact same effect as a ball screw assembly, but without the inflated cost. Next is our spring assembly. We used some wide end springs to press against the plastic panel on the board. And these are our 3D printed part, which then bites into the eraser with its teeth. This ensures that it has even pressure along the whiteboard assembly as a whole. And that's pretty much everything with the CAD design.